Our previous video taught you how to do a x86 trampoline hook. We're going to expand upon that, and we're going to create a hooking class. We're going to use that class to hook swap buffers. We're going to teach you how to draw in OpenGL and render text. And we're going to use those two skills to make an ESP box that looks like this. If you like our videos, guidedhacking.com/donate and patreon.com/guidedhacking. So if we grab the source code from that trampoline hook video, it looks like this. Just to briefly go over it, we have our create thread here, we have our hack thread, we have our trampoline hook, which hooks swap buffers. This is our swap buffers hook, and inside of it, we have all of our little hack items, and then it calls the original swap buffers via the trampoline gateway. First thing we're going to do is write our hooking class. In the previous video, we had put our trampoline hook functions inside of our memory library. We're going to take those out of there by cutting them, and if you'll notice, I've already made hook files, GL text, and GL draw, so go ahead and make those now if you're following along. So let's go into hook.h and let's paste those in. Let's go back to mem and let's grab those hooking functions as well. Paste them in the source file. Let's go into hook.h and put our stuff in here that we need. We're going to include windows.h, and we are going to include mem.h, and that should be everything that we need. Now, we need to define our hook class. So we're not going to use a class, we're actually just going to use a structure, and let's go in here and do bool b status, and we're going to initialize it to false. We have a byte pointer, source, null pointer. We're going to copy 3 of these, and this is going to be destination. This is going to be a pointer to gateway pointer. And then we have int length, which will initialize to 0. Let's do byte, original bytes. We're going to just use a hard-coded 10. That should be big enough for any original bytes you're going to overwrite. And as usual, I'm gonna code each section and then explain it to you. So hook, byte pointer, source, byte pointer, destination, byte pointer, pointer to gateway pointer, and uint pointer underscore t length. And we should actually do that up there as well. And fix that. And we're gonna have a second hook initializer. Constructor, constant char pointer, export name, constant char pointer, mod name, byte pointer, destination, byte pointer, pointer to gateway pointer, uint pointer underscore t length. I really can't type lately. This is way worse than normal. Void enable. See? Terrible. Void disable. And void toggle. You're probably never going to need that toggle function, but we're going to put it in there anyways. Alright, we need to fix a typo right here, and let's grab these because we need to define them in the source file. Let's paste them down here. I'm also realizing we need to get rid of that mem namespace we were using from before. And let's go back down here and add some function bodies. So this is just our constructor here, just our regular one. So this source equals source. We just basically taking local copies of the variables that we're passing in. And this pointer to gateway function pointer equals that. Bro, you're killing me. Alright, we're going to do basically the same thing for this constructor, except we're going to get source via the exported function. So it's hmodule hmod equals get module handle a mod name. And then over here, we're going to cast to a byte pointer and get proc address hmod export name. And then everything else stays the same. Enable, I'm going to do memcopy, original bytes, source, length, done. And then we're going to do pointer to gateway pointer equals tramp hook 32 source destination length, and I think we need to cast that to a UN pointer underscore T, and we need to do this. We need to cast this as well, and then get the value pointed to by the pointer that we're casting to it. And then we're going to set B status equals true. Then inside disable here, we're going to do mem patch source original bytes length, and we need to cast a source. No, we're good. Toggle is just going to do if B status enable else disable. And this needs a not in there. I think that's that. I just realized I've made two horrible mistakes in this code. So number one is these need to be hook, scope resolution hook. Same here. Actually, same on all these, huh? Yeah, I can't believe I fucked that up. Okay. And you know what else I did is I named this variable wrong. So pointer to function gateway is supposed to be function pointer. So we have to just replace all those with the correct one, including that one. And then what else did we screw up, Rake? Idiot. Original bytes with an S. Okay. Now we should be Gucci. B status equals false as well. And then original bytes. Come on, bro. Why isn't that compiling? Because it's not byte pointer. It's just a regular byte array. And now it should be good. Okay, thank you. All right, let's go to the top and explain this. We all already know detour. We already know tramp hook. This is just a constructor. Keep in mind that this is going to be a little bit confusing right here. So when we write that, when we call us later, you'll see why. So this is just our basic constructor, and then this one is our wrapper around kind of the original constructor, in which we get the process address by getting it from the export table by using get proc address. So we get the module name, get proc address. So we would like the export name is going to be SwapBuffers, and the module name is going to be OpenGL32.dll. And enabling it, we copy the bytes so that we can restore them later, and then we're going to perform the hook against our pointer to the gateway function pointer. And so basically this is being passed as byte pointer, and we need to set its value that it points to, the function pointer, we want to point at the gateway that trampoline hook returns. So that's why we're going from byte pointer to a pointer, and then we're getting the value of it and setting it. And then disable is just patching the original bytes back over, and toggle just enables it and disables it. Easy. So let's go over into gldraw.h. We need to do a few things. We need to do pragma comment lib OpenGL32.lib. I think that's what it is. And we need to include Windows. We need to include stdio.h. Maybe not. Include gl.h. We're going to include mem.h, not meme. I wish I had meme.h, that'd be nice. And then we're going to do, we want some colors, so we're going to do namespace RGB and constant GLU byte red 3 equals 255, comma 0, comma 0. We're going to copy this 1, 2, 3, 4, 5 times. We're going to do red, green, gray, light gray, and black. And so these colors are 0, 255, 0. We got 55, 55, 55 for gray, and then I like for light gray 192, 192, 192, and then black is just all zeros. And so those are our little colors we're going to be using. And then we have namespace GL. In this namespace, we are going to have void setup ortho. That's an orthographic projection matrix. And we have restore. Holy shnikes. I hate making these tutorials, to be honest. I can't stand every second of this. Void, draw, fill. I just do this for you guys. You know, you guys want videos? I make them. I'd rather just post text tutorials any day. Draw, fill, direct, float X, float Y, float width, float height, constant GLU, byte, color, 3. And then we're going to copy that, and we're going to do draw outline. And that's going to have the same arguments, except it's going to have another one, which is float line width. And let's grab these, and let's go to source. And let's do the same thing we always do, but let's not screw it up this time, Rake. Because we are smart now. Yes, look at that. Okay. So first thing, set up ortho. We are going to do GL push attrib, and it's going to be GL all attrib bits. And GL push matrix, GL int viewport for GL get integer, GL viewport, GL viewport 0, 0, viewport 2, viewport 3. GL matrix mode, GL projection, GL load identity, and then the whole reason we're doing this is for GL ortho 0, viewport 2, viewport 3, 0, -1, 1, GL matrix mode, GL model view, and then GL load identity, and then GL disable. I know you're looking at this like, what the hell is all this stuff? GL depth test is the last one we need. Now, what is all this junk? All of this is OpenGL stuff, which if you had done the tutorials on the view matrix, I believe I have 2 of them, and I have a big guide on the website as well, and that should pretty much cover everything you need to know about this. So watch those, please. Lowercase p. So basically, in order to do 2D drawing on the screen, we're going to use an orthographic projection matrix, and we need to create that matrix because the game is currently going to be in like a 3D projection matrix, and we need to set up an orthographic so we can do regular 2D. We need to disable depth test so that whatever we draw on the screen is going to be on the top layer, and it's not going to be like hidden behind anything. If anything draws after this, then we want it to be on top, so we disable the depth buffer. Basically, these are wrappers. Before we draw, we're going to call this, and then after draw, we're going to call that. So we're going to push these attributes. Basically, you can think of OpenGL as like a state machine, and it has all these different attributes and states that are all set for the current drawing that it's going to be doing, and then those states are changed when they go into different phases of drawing what's on your screen as they build like the 3D game world around you, right? So we need to get into a different state, which is the orthographic projection mode, so that we can draw in 2D. So we're going to push all these bits, and later we're going to pop them. We're going to push the matrix onto the matrix stack, and then we're going to pop off of it later. The viewport is defined as 4 integers. I think you can do float as well, and it's X, Y position of the viewport, and then the width and height of the window. So we're going to call GL get integer, and we're going to get the viewport, and we're going to get it in integer format, and we're going to store it into viewport. So then we're going to set our viewport by using GL viewport. X and Y are 0 and 0 because that's how all games are set up, right? The top left of the window is 0, and viewport 2 is the width, and viewport 3 is the height. So we're creating this matrix mode so that we can draw. So then we're going to set matrix mode into projection mode. We're going to call load identity, which loads a it's almost like a blank view matrix, you could say. It's the one where it's just zeros and ones, right? And then we have GL ortho, which is going to create an orthographic projection matrix, which is what you use when you're doing 2D. And you have the left, which is 0, right? This is going to be the far right, so that's the width. And then this is Y, which is height. And then, let's see, the last ones are top, near, and far. So top is 0, just like top is 0 up here. And then you have near and far. So we're basically defining, it's called the frustrum. If you watch my other videos on view matrix, you'll get a better idea what that means. And for this game, for Assault Cube, it's -1 and 1 is the near and far. Sometimes these are swapped. Sometimes it's 0 and 1. Sometimes it's -2 and +2. So you have to kind of guess and get it to work in your game. Now, what you can also do is you can use something like, what's that thing? There's some API hooking program. I forget the name of it off the top of my head here. But you can use that, and it'll hook all of these GL functions for you, and you can find out what it's passing as arguments. So if you see the game always passing in -1 and 1, then you can be pretty sure that that's what you want to do as well. We're then going to set the matrix mode into model view because we're about to draw some 2D boxes and text onto the screen. So that we want to be in model view mode, right? And then we're going to load the identity, and we're going, again, basically setting it just like a default identity matrix, and then we're going to disable the depth test. So now we've set up our orthographic, and now we're going to just draw it to the screen. And so after we do our drawing, we're going to do restore GL. And this is going to be real easy. It's going to be GL pop matrix and GL pop attrib. Now that should, basically everything we've done here will have been probably reversed by using these. Every game is going to be different, okay? Because we don't know where are these things being set. They could be being set in another thread. We really don't know how it's working. So in every game it's different. In Open Arena, which is another old OpenGL game, it was very, very similar, but I think I had to change 2 variables. So it's kind of like a trial and error thing. You'll definitely want to use the API hooking thing, the logger, and get an idea of what the game itself is calling and what it's passing as arguments. All right, so now let's draw some shapes here. We're down in draw filled rectangle. Let's GL color 3 UB. We're going to do color 0, color 1, color 2. And then we're going to do GL begin. And we're going to use the type GL quads, GL vertex to F, X, Y, GL vertex to F, X plus width, Y, GL vertex to F, X plus width, Y plus height, GL vertex to F, X, comma, Y plus height. And then we're going to do GL end. So what are we looking at here? This is called immediate mode. So there are actually 3 ways that you can draw in OpenGL. There might even be more now. But this is called immediate mode. So this is in OpenGL 1.0 and kind of 2.0. There's been many different versions. But in the original 1 and 2, this was the main method of drawing. It's called immediate mode. And whenever you see GL begin and end, that's immediate mode. And GL quads is just a rectangle, something you would use for drawing a rectangle, okay? So the first vertex is going to be the top left, top right, bottom left. And when you use GL quads, it knows to connect that last line from the bottom left back to the top left. And anytime you're drawing, you want to typically always starting in the top left and going clockwise. That's like standard operating procedure for drawing shapes. So let's go down into outline, GL line width, GL begin, GL line strip, GL color 3UB, color 0, color 1, color 2. And now we're basically going to do the same thing here, except it's going to be slightly different. So I'm calling this an outline function. So you're going to, later down the road, you're going to want to draw outlines around everything to make it looks distinctive. So my outline function, it can be used just for drawing a rectangle that's unfilled, and it can also be used to slap right on top of a box that's already drawn. So it's going to be x minus 0.5f, and what that's going to do is it's going to this box, by doing the minus and the plus 0.5, it's going to overlap the currently drawn box. So basically, no matter what size you use for your filled rectangle, when you slap an outline on top of it, this is going to make it so there's no spaces or empty space in between the outline and the box itself. All right, this next part is going to be very similar to the above function, but it's going to be x minus 0.5f, and we're going to put that down here with each of the x's as well. And then with the heights, we're going to do the same. And with this y here, and then this one's going to be y 0.5f. Epic typing again, Rake. Actually, we're going to do plus 0.5f here as well. This is going to be y plus height plus 0.5f. This is going to be x minus 0.5f, y plus height plus this, minus this, minus this. Sorry, I'm just copying off my notes here. And we need another GL vertex line. It's going to be x plus width plus 0.5f, and this is going to be subtract. And then at the end, we're going to do GL end. So all this OpenGL stuff, you can just look this up in the OpenGL documentation. It's very good. This is called immediate mode, right? So up here, we have GL begin, and the mode we're setting is GL quads. And so this has a very specific definition, right? What it does in immediate mode is it says each vertex which is added by using GL vertex is going to be a vertice inside of a rectangle, and it knows that at the end you're going to connect the last vertice to the first vertice with a line. So it's saying connect each one of these vertices, and then that special thing with the last one. Now the 2f means it's taking two variables and they are floats, right? And if we go down here, we're doing GL color 3UB. UB just means unsigned byte or unsigned char. And we're using GL begin here. And when we're doing a line strip, we can define the line width. Up here, we want it the same size every time. But down here, your outline, depending how distinct you want your border, you can change the line width. Now, GL line strip, if you look up GL line strip, what it says is that each vertice that is defined between GL begin and GL end, it's going to connect those with a line. Actually noticing an error right here. I think this is just going to be y minus 0.5f. Yeah. All right, so draw outline, right? We are using a line strip, and what that means is that each one of the vertices is going to be connected by a line. And why are we doing minus and plus 0.5f? Because this is going to allow us to draw a border that is always connected to the rectangle. If what you're going to be doing a lot with this is you're going to be drawing borders like around your menu and stuff, and because you want to make it distinct, like a lot of time with ESP boxes as well, you draw a outline around your outline, and that makes it look cooler, right? It makes it pop. So when you're using draw outline, using this is going to set it a very small amount to the left, to the right, to the top, and below the actual rectangle. But it's going to make sure it's connected, so that if you were to take a box and a border and you were to scale it based on distance, which you'll be doing in an ESP, this will ensure that your border and your rectangle are always touching, and there's never any blank space in between them. All right, let's make sure this compiles. It does.